Hey, I thought I would make a video on magic squares, just kind of talking about squares, especially the 3 by 3 case, just because I think it's kind of an interesting thing in mathematics, and it kind of opens the door for some interesting sections of mathematics that we might not get to, but just kind of is a nice little introduction to some cool things. What is a magic square? A magic square is a set of tiles. This case right here, we have a 3 by 3 set of tiles where row, every row and every column add up to the same value, and the diagonals will also add up to the same value. So, what is that value? It's not really known, or at least it's not something that we know until we can go through and solve it. It's something that we must solve for. What is the other restraints? Well, in this case, we're going to consider a magic square where the possible entries are 1 through 9, and I'm going to include 1 and 9, and we can't have any repeats. So this means we have to use every number between 1 and 9 one time. So let's think about this. We could always try just going with a bunch of different numbers, and maybe we could find ways to do an educated guess, but is there a way to 100% certainly find the number that everything will add up to and show that that is the only possible number that these values can add up to? Let's think about that. So, first, what is the smallest possible number that could be? What is the smallest possible number that we could use? Well, if we kind of just go at this really brute force, we can see that 1, 2, 3, the smallest possible number is 6, but that's kind of a simple approach. Let's think about this just a little bit more, let's go at it a little bit more mathematically minded. So let's try to kind of consider the worst case. We know we're going to have one of these rows and columns are going to have a 9 in it. So let's put the 9 here. Now, if you think about it, where we put this 9, there's only really 3 cases for where we put this 9. We can either put it here, because this is going to be the same as putting it here, here, and here for our first placement, or we could put it here, which would be the same as putting it here, here, and here, or finally we could put it in the center. Now, if we put it wherever I have 1 dash, note that there would have to be 2 times that 9 would have to add up to get whatever value we're looking for. I'm going to call this value n. Whenever I want to call it the value that all these rows and columns and diagonals should be adding up to, I'm just going to refer to that as n until we get into guessing or saying what it is. So there's 2 different ways that we would have to add numbers to get 9 up to n without going over. So let's see. If we put 9 here, now there'd have to be 3 ways. So that's worse. And then here we'd have to have 1, 2, 3, 4 different ways. So that's even worse. So let's give ourselves the best case scenario with a 9, that it would be right here on one of these 4 spots. So if the 9 is in one of these 4 spots, it doesn't exist on the diagonals, doesn't have any diagonals to worry about, we need to have 2 different ways that we'll add values between 1 and 8 to our 9 in order to get n. So 9 equals, my apologies. So let's see. 2 different ways. So what is the smallest number we could have? 9 plus 1 plus 2. So this would give us 12. That means the absolute smallest value for n would be 12, but really, if you think about it, we have to find 2 different ways of writing this. And if we write it as 9 plus 1 plus 2, there's no other way to get a value as small as 12, so really, we would have to use 9 plus 1 plus 3, which equals 13, and then 9 plus 2 plus 5. Oh, that's actually, oh, my apologies, 4. And that would be, let's see, so 11, 15. So that doesn't work either. So really, the highest value is looking like it can't be 13. Let's thinking this might indicate to me that the highest value or the lowest value is 15. Let's think through this. Let's assume that the highest value is, let's say, 14. So 14 minus 9 equals 9. That 14 minus 9 equals 5. So how can we write 5? 5 equals, we can write that as 2 plus 3. We could also write it as 1 plus 4. So actually this wouldn't be the correct way to go about it. We would want it as 9 plus 2 plus 4, and that would give us 14, and we would also have 9 plus 1 plus 4, and that equals 14. So we do have a way that we can let our 9 work for this to get 14. So let's examine that. So if we put 9 in one of these boxes, and we say we're looking for an n equals 14, does this work? So we knew from earlier that we would need to have 1 with 4, or one of the boxes would have to have 1 would have to have 4, 1 would have to have 2, and 1 would have to have 3. Does this orientation work? So let's think. Well, if this is 2, that's 1, so this is 3. There's no way that a value here can satisfy this. There's no value here that will let us get in on our diagonal. So we know that this isn't going to work. So let's instead flip this 1 and 4. So let's make this 4 and this 1. Now, let's see here. So we have 9 plus 4 plus 1, so all of this seems to be working. So let's see. 2 plus 4 is 6. That means if we want our final value to work out, to get 14, we would need to put an 8 here. So let's see. 2 plus 4, 6, plus 8, 14. This is good. 3 plus 4, 7. So we need a 7 here. Now the problem is if we have a 7 here and an 8 here, then this row here will be 16. So this isn't going to work. Let's look at that again. So if we have a 9 here and a 2 here, a 3 here, there's no way that I can orient a 4 or a 1 between these two spaces. They'll end up letting me work things out. The best way to go is to put a 4 here, 1 here, but the problem is then I have to put a 8 here, and then I have to put a 7 here, and by just going through what I have to put, I've run into an issue where that doesn't get my number to be right at the end. So I know that a 4 and a 1 can't be the values that go here. So where does that leave us if we want to use 9 with n equals 14? Well, let's see if we can work this through if I have a 1 here and a 4 here. 2 and 3. So if I have the 1 here and the 2 here, putting an 8 here isn't going to get me my 14, so this orientation already doesn't work. Flipping this orientation to make this 3 and this 2, well, likewise, we have a 4, we would need a 10 here, and we can't put a 10 there. So that's not going to work either. That means that n equals 14. That's too small. We need n equals 15, or n is greater than 15. So we run into something that looks like this. Okay, so let's think about this. Now, let's kind of examine it the other way around. So now we know n has to be greater than or equal to 15. But what is the largest possible value of n? So let's see. We know no matter what, this is going to be very similar to the previous kind of approach, where we know no matter what, we are going to have to fit a 1 in here. Best case scenario, our 1 is going to be where it's only in one row and one column. So let's try putting it here. Now, let's see here. We know that we need to have these values for one add up to be some number for n. So, what is the biggest possible value we can get with this? 1 plus 9 plus 8 equals 18. So 18 is going to be the, instantly we know it can't be any bigger than 18. But really, we need two different ways to add this up. So 1 plus, let's see, 7 plus 9, and 1 plus 6 plus 8. So this would give us 17 and, let's see here, 15, 1 second, didn't quite work out. I think we'd probably want this to be 7 and 8, and this would be 6 and 9. So this would be 15, 16, that's good. This would be 16 as well. Okay. So with this, the issue was that there was only one way to add up my 1 plus 9 plus 8 to get 18. I needed another way. And so what we would see is that in order to get it to something that we can add up in two different ways, we'd need to use 16. So with that being said, let's try these different values. So we have 1 plus 7 plus 8 equals 16. Then we have 1 plus 6 plus 9 equals 16. So here are two different ways to get 16. There's no other combination of values that will let us get 16, assuming that we have this 1 and that we can only use each value one time. So, with that being said, let's go up here and try writing our values. So we are going to have, let's say, 7 and 8, 9 and 6. So here, let's kind of go through and see what happens. We are trying to show that n can be 16, so we're kind of trying to work through to see if we can find a magic square for n equals 16, sorry, assuming that a 1 goes here, which is going to be our best case scenario. So if I put my 1 here, I have 8 plus 9 equals 17. So already this orientation is bunk. So we're going to switch my 9 and my 6. So this should hopefully give us a better way to go. What is 8 plus 6? That's going to be 14. And so we need to have a 2 here. So what is 7 plus 6? 13. And so since we're wanting 16, we need a 3 here. But see, 9 plus 2, 11, that would be 14. So this wouldn't work. So this is very similar to the case where we were trying to use 9 instead of 1. But we see that that wasn't good. So now let's switch this around and see what happens for this case. We are trying to find the magic square for n equals 16 by considering all the possible orientations, letting 1 go here. And I think it's not too hard to see that if I let 1 go somewhere else, we're going to have a worse situation. So this is best case scenario, letting 1 be on one of these 4 squares. And then working through and trying to find the magic square when we assume that n equals 16. So, let's see here. For this case, 9 plus 7, that's 16. So this is already not going to work. There's no value here that will give me a sum of 16 when I add these up. So, and furthermore, really, that's kind of the death of this n equals 16 try, because if I make this an 8 and this is 7, we run into the same issue. So what I've shown is n can't be 16. And really, if n can't equal 16, because essentially this 1 is too small. I have to use too big of numbers to bring this 1 up for n equals 16 to work. That kind of throws a bit of a problem to n equals 17, 18, 19, and on and up. A more rigorous proof could be given, but I think that really gives a fairly good description on why. Trying to bring this 1 up when n equals 16 throws too many difficulties for our magic square, so it seems like any value of n higher than 16 would likewise be impossible. So that kind of indicates to us that n equals 15 is probably the way to go, if there is a way to go. So, because we know that n can't be 16 or higher, and it can't be 14 or less, so let's think about n equals 15. Now naturally, we could just throw values down and try for different things, but let's kind of take the same approach we've been taking, where we say, well, I think 1 is going to go here, and really, what are the different ways that I can add up my 1 with some of the higher values to get 15? So I can add 1 plus 9 plus 5, that's going to be 15. 1 plus 8 plus 6, that's going to be 15. And then let's see, well, 1 plus 7 plus, so that wouldn't work. So really there's only 2 ways to add up my 1 with 2 other values to get 15. And that's very good because we need 2 different values. So let's see here. If I take my 1 plus 9 plus 5 gives me 15, and my 1 plus 8 plus 6 gives me 15, let's kind of think of where we want to put our 9. Now we probably don't want to put our 9 here or here, because this would give us 3 different ways that we would need to add up our values, and 9 is kind of the problem value. 9 and 1 are kind of the problem values for working through our magic square. So really, we would want to put it, well, we wouldn't want to put it here, right? Because this would be the worst case scenario. There's 4 different ways. So 9 really should go here, because it has the least number of ways that we would need to add other values up with 9 in order to get our 15. So it seems reasonable that 9 would want to go there. Now, this kind of means that our 5 will need to go there, and then we'll have an 8 and a 6 in one of these 2 places. I think an argument of symmetry could be made that would make it such that it doesn't matter where we put it, so let's just put the 8 there and the 6 there. Now, let's kind of just work through and see what happens. And so, what is 8 plus 5? That's 13, so we need to have a 2 there. So 9 plus 2 is 11, and so we need a 4 there. So 8 plus 4, that's going to give me 12. I need a 3 there. 6 plus 2 is 8, so in order to get 15, I need a 7 there. So here, without guessing, we found our magic square. 8 plus 3 is 11, plus 4, 15. 9 plus 1 plus 5, 15. 2 plus 6 is 8, plus 7, 15. 4 plus 6 is 10, plus 5, 15. 2 plus 8, 10, plus 5, 15. 2 plus 4, 6, then plus 9, 15. 7 plus 3, 10, plus 5, 15. 6 plus 1, 7, plus 8, 15. So here we were able to find the magic square without doing any really kind of guesswork. I think this kind of shows a approach that could be done to to write out a more rigorous proof, but I kind of omitted that because I kind of just wanted everyone to see what was going on and how we were able to find the magic square without guessing one time. So thank you very much for watching. If you have any questions, just let me know.